Okay, we're going to look at a couple more examples of just finding critical points. Remember that so far all we're doing is looking for where these critical points occur. We're not actually trying to classify them further. Okay, so we have a piecewise defined function. I see that this piece is a line, right? Y equals mx plus b. And this piece is a cubic. So each of the pieces themselves are quite simple looking functions. I don't have anything where the derivative is undefined or 0 or anything crazy happening. Well, actually, I shouldn't say 0 yet, but certainly nothing undefined. But how do I actually go about finding the derivative of a piecewise defined function? Well, while we're on a particular piece, like the derivative of 2x minus 1, that's going to be 2, right? And that's going to be true when I'm everywhere on this line except potentially at the end point, right? When I switch from one piece to the other, I have to think a little bit more carefully. But certainly for all the values leading up to 1, my function's going to have a constant slope of 2. For the next piece, the derivative would be 3x squared, and that's certainly going to be true for values of x greater than 1. But what's happening at x equals 1? So what we want to do is think about this as a two-sided derivative, right? So I have this function 2x minus 1, so it's got a slope of 2, looks something like this, right? And then at 1, it suddenly switches to x cubed, right? So the question is this happening in a way where the derivative is defined? And the answer is no, because from the left, as I approach 1, certainly this is just a slope of 2. That's constant. As I approach 1 from the right, the slope is 3 times 1 squared, or 3, right? So coming from this direction, the slope is 3, and coming from this direction, the slope is 2. So right at x equals 1, the derivative is undefined. Okay, and I meant to write f prime, sorry, f prime of x. Okay, so we're asked to find critical points. So we're looking for places where f prime is either 0 or undefined. Well, one of them is screaming out at us, right? We see that we have a critical point, obviously, at 1, comma something. We'll go back to that. That's this point right here, right? This looks like a critical point. We've got 1, comma something. In fact, we can see it's a critical point, but it's not going to be one that's a maximum or a minimum. But what about f prime being 0? Is there a place where these functions are 0? Well, 2 is never 0, right? But what about 3x squared? That would certainly, 3x squared is 0. Let's solve for where that would happen. This is obviously happening at 0, so I don't know why I'm going through the algebra. It's happening at x equals 0. But x equals 0 is not, so x equals 0 not in this piece of the domain, right? Where x is 0, that's not on this curve. So we're not getting any critical values from this piece either. So the only critical value is right where the derivative is undefined. That's going to be at this point 1, comma 1. So that's our only critical point. Okay, one more example. And again, I'd ask you to pause the video and take the derivative of y here on your own just for practice. It is definitely a necessity for you to be able to take derivatives of functions if we're going to be looking for, remember, where is f prime equals 0 and undefined. Okay, or in this case, y prime. Okay, so with a little bit of simplifying, we have the numerator is 2x plus 2, and our denominator is that inside function, x squared plus 2x plus 3. So we know that y prime will be 0 exactly when the numerator is equal to 0, and we know that y prime will be undefined exactly where the denominator is equal to 0. So we have to solve both of these equations over here. This one out by just subtracting 2 and then dividing by 2. We're going to see x equals -1 as a critical value. But this guy to solve, it's a quadratic. Our first instinct might be to factor it, but after a little bit of thinking, I hope you'd realize that in fact this doesn't factor. So we do need to solve it using quadratic formula. That's this guy, right? So using quadratic formula, we get x would be equal to 2 plus or minus the square root of -8 over 2. But once we get that square root of a negative number, this is a non-real solution, right? It's a complex number. So we're not getting any real critical numbers here. We just have this one critical value at x equals -1. So the critical point occurs at -1, comma, when I put -1 back into my original function, I get natural log of 2. And so that's pretty good with practice in terms of finding critical points. Certainly you're going to need some more practice, but that gives you an overview of how to find them.